furnace is of cylindrical shape and its radius and height is of 2 meter, and the base top and side surface having corresponding temperature 500 Kelvin, 700 Kelvin and 1200 Kelvin. What you have to find is the net rate of radiation heat transfer to or from the top surface during steady operation. Okay, we have to find the radiation heat transfer from the top surface to the bottom and the curved one. So let's look at the solution. So we have cylinder having temperature at three parts and bottom, top, and curved surface. The bottom is having 500 Kelvin temperature, and the curved one 1200 and top one 700 Kelvin. And this is the given condition. I mean, the radius of the cylinder and height or length of the cylinder is 2 meter. They are both same. So what we are asked is to find the radiation heat transfer on the top surface from the top surface. That means we have to find the heat transfer, total heat transfer on the top to the curved one and the bottom one. So here we have a cylinder which is symmetrical. I mean, if you cut off by any plane, I mean, the radiation heat transfer from the top surface will be the sum of the heat transfer to the curved one and the bottom. I mean, total heat transfer from the top is sum of transfer towards the curved body and the bottom surface. That is what I have written there. The total heat transfer, the sum of the heat transfer from this 1 to 2 means top to bottom between those two faces, and 1 to 3 means the top and the curved faces. So the individual, I mean net sum of the individual heat transfer from the top and curved is the total radiation heat transfer from the top surface. So first of all, we need to find the parameters for solving this problem. We have all the value, the area A1. Since we are considering from the top surface, we have to consider the area of the top surface. Since we have radius of the cylinder, we can simply find the area of cylinder, but we don't have the value of the view factor F12 and F1. So the view factor has to be found by graphical method. Okay, I will show you the graph. So this is a graph for finding the shape factor, view factor, and this can be find out the heat transfer data book. So we need to find this value. The smaller side of diameter by distance between the plate. Okay. So what I need to find is F12. Then this is the top and bottom plane. So the distance between the plane means that the given height is 2. And the smaller side or diameter, what you have given is radius. So the diameter will be 4. 4 by 2, 2. So from this curve, we can see 1 to 5, 1 and 5 represent disk. And in addition to that, you can see direct radiation between the planes. So the top and bottom plane can be considered. You can include in this category direct radiation between the planes than disk, because you can see the it's plane. Both planes are parallelly arranged. So basically, it will be direct radiation between the planes. So uh, you should consider the one. One should be the curved line you should consider. I got the ratios too. So all I have to do is just, if we keep going like this, it will intersect at one, and the corresponding point will be approximately this point. Okay, it will be somewhere around here. So from that value, approximately it will be 0.38. Okay. So from graphical method F12, so the V factor between first and top and bottom is 0.38. Then what I need to do is apply the summation rule in order to find the remaining V factor. From summation rule, you can write with respect to any surface. You could be write it with respect to curved surface, top surface, bottom surface. Since we need to find the transfer from the top surface, I will be writing the summation rule with respect to top surface. So from that point view, you can write F11 plus F12 plus F13 equal to 1. Right, the total radiation from the 1. The total fraction will be 1. So by summation rule, I can write like this, but in the actual case, the F11 is not possible. 1 to 1 radiation transfer is not possible. It will only fall to 2 and 3. So F11 is 0. So the remaining F12 plus F13 equal to 1. I already know the value of F12 as 0.38. So F13 is 0.62. So I got both the view factor between the first and second body and first and third body. and all you have to do is substitute the value in the first equation, this equation, main equation. So substituting the value in order, we get the value as minus 762 kilowatt. It's a radiation heat transfer from the top surface. So I got the values minus 760 kilowatt means the heat transfer is not happening from the top surface. It is acting towards the top surface. I mean this uh, curved surface, and we have this bottom 500 Kelvin surface. So net heat transfer considering all this is towards the top surface. We are in this question also you can see we are asked towards or from the top surface, because this only be confirmed from the final value. Uh, so from the final value is negative, that indicate we have considered from the assume from the top to bottom, right? But the answer is negative means the actual case it is opposite direction. So the heat transfer is towards the top surface. Okay.